OK，其实已经9点15分 but we'll spend the first few minutes we set up these technical things because today we'll be doing more lab work as I said, and we're going to go through the assignment questions and then like we're going to share with each other questions, problems, and solutions or whatever. So just for the first few minutes, let me set up the technical things so that we can start the lab today. OK。所以等一下会用 we're going to use the screens and we're going to go through the assignments, okay? And then we're going to do basically lab interactions today. So let me see, neural networks. And we're going to go through assignment 1. Where are we at? Okay, here. This is big enough? Okay. How? So in each of your tables, there is the box with the either the Chromecast things or the HDMI cables. Ben, you have one behind you as well. So every screen has one. And later, I leave it up to you. You all want to sit together and share one screen, or you all want to spread out and each person can have your own big screen to work. It's up to you. Every screen will have a box there, and you can find either the HDMI cable, or you can use the Chromecast, or if it's a Mac, AirPlay method to connect to the screens. And later we will be going through step by step, or rather you will be going through step by step assignment 1, and then I'll kind of have you guys show everyone go one round to show like how you do the first or second or third question. I actually did the first 2 questions last week. So maybe we will start with question 3 today, right? And then we'll work through all the questions to the end of class. You likely won't finish everything today, but it's kind of to get you started. And then you can, and next week we'll be doing back prop, but then so on your own from today's interaction, on your own for the next few weeks, you can sort out the Hopfield network, and then the assignment is due on the 15th of May, right? Okay? All right, so let's just go through. Can you all see? I don't know, the words are very small still. Hang on. 真是太小了。Is there a way to make this so that it's Okay, I guess that works, right? That's better. Okay, so I'll set this up first. Okay, then we'll spend the first couple of minutes sorting out the. Later, if when you all share, you all must use the mic. Otherwise, other people can help. The video recording cannot hear you. Okay, then Yeah, if you guys can also take out there, I think there's the longest HDMI cable. HDMI 是最容易的，最直接的。如果需要 adapter，这边有 adapter。Yeah, OK. 如果你的那个从 Lightning or USB-C 到 HDMI, if you need it, then there's one here. OK. And if you need a longer cable, 其实这边你也可以用这个 ，feel free to use this one. 如果需要更长的，OK. Yeah. 我先放这里。Or you can try the Chromecast or whatever. Maybe 那边有更长的吗？看一下。诶，有嘞。来，这样可能这个比较好。好，那个应该够长哈，应该可以。Okay, if we need more, we have supplies here, so we should be good. Okay, then let me figure things out first. So that your screen is that one. So if I say this one and this one. 哦，不对，这个是前提，这个是不是？哦，它只是很迟钝而已。现在这个是你们的 screen. Yeah. Okay. Looks like it. Okay. All right. So first, let's talk about. Let's just open this time up first. Any questions from the past couple of lectures on Hopfield network and autoencoding? Any questions? Yeah, William, I think you need to choose the 那个无线什么什么 on 右边 ，Yeah， 无线投影，然后你按那个荧幕上面，等一下它 loading 的那个你就按，它好了你就，诶，好像有了诶，哦对，这个，So it's very complicated. I don't know. I think you need to do something where you log into the SSID. You see the thing on top. There's a little bracket arrow on top. You have to tap that on the screen. Oh yeah, the SSID there. Yeah, I think you have to do something where you link to it and then it's okay. I don't know. Very complicated. I told the 那个管理房间这个教室的那个人员说，诶，我们不能就用 AI 管理这教室吗？就是我讲说，诶，教室 future classroom，please put this screen on that screen，然后他就就可以了，不就很更 future 吗？毕竟 AI 现在可以了解啊，所以至少这个。所以就讲就可以了，不用什么哦，调这个按这个啊，调这个按这个，太复杂了。有啊，I don't know. I think at the end of the day, you just use the HDMI cable is the easiest. Okay. All right. No questions about Hopfield network. So the idea here is then, therefore, you can, you can do it on your own, huh? Yeah, no questions means you can handle the Hopfield network, huh? Correct. 诶，为什么这样就跳出来？不要啊，OK。Well, okay. I'm sure your questions will come up along the way as we go along. Any? You all understand what the Hopfield network does, right? Conceptually, right? Basically, fundamentally. Um, and you have the Colab and the sort of Python way. You also know how to, like, if you want to test it or make it, you know, what are some basic steps? What are the components? You need the activation function, the architecture, the learning rule, all that, right? And I gave you the Colab and brought you through the demo of how to implement it in a coding sort of scenario. You set up the the training network, which is the learning rule, and the activation function, which is the testing part of it, right? To make it actually activate. The Hopfield network tutorial, we do it this way. Obviously, you might implement it in different ways for different scenarios, but this is just in the class setting. This is how we set it up, okay? All right, so theoretically, you can make your own Hopfield network now, okay? So let's go through the exercises. And I said today I'll have people go maybe one round very quickly. If you can, we'll talk through the first questions, and then we'll take turns, go one round to kind of show everyone, or you want to ask your questions, or you have some things you can show everyone. We project on the screen, and then we can see, you know, what's your solution, how you approach it, how you did it, or you can tell people, this is what I've done. I'm stuck here, and you know, I haven't done a lot or very little, doesn't matter, okay? Because maybe everyone can learn from different viewpoints or perspectives, all right? So that's what we will do today as we go through each questions one at a time. Okay, so for the first one, build your own binary autoencoder. I did that last week, all right, with the Google Colab. So actually, yeah, why don't I just also put up my solution as well. It should be Hopfield. This is mine. All right, maybe more. Okay. So yeah, so this is my solution, and I don't expect, you know, everyone would have followed me in class. So this first one, I think is okay, right? Everyone okay with question one? Does anyone have any problem with question one? Huh? Please don't be shy. Today is a lab, so if you have problem, you should say, and then we work iteratively, okay, interactively. Okay, so no, right? All good. And if you, I mean it, because, you know, we're not gonna go back. So this is the data table, and that you're gonna set up, and all the visualizations. So if you implement a Hopfield network, as we did last week, I went through, you will get all these architectures, and you will have this learning rule. Essentially, what it means is that when you set up the Hopfield network, binary autoencoder or Hopfield network with this settings, question 1 and 2 really goes together. Then you are going to train your network with the W that looks like this, right? After you train your network, you will have a W matrix that will look like that, okay? As you visualize it in a heat map. Correct? Everyone okay with this so far? Okay. All right. So then let's go to question 2. And here is where I didn't really do so much. I set the basics up. And here is where I will need, you know, let's go through the different parts of this question 3 during this class at this moment. So can I have all of you set up your Hopfield networks so that you can, and your distortion patterns, okay? So we have the arrays and the training functions and the distortion functions, right? And then you can train and distort and train and distort. Okay, so can I see, maybe let's go one round and then show, has everyone sort of tried a little bit in your own code? You haven't even started yet? Okay, why don't we start now then? Okay? If you haven't started, that's fine also. So then why don't we get started today, right now? Okay? So I want you guys to open your Jupyter environments or your Python environments, however one you want. And let's do this. Okay? Feel free to just copy my Colab first at least for the first few parts. It's fine. All right? Because it's going to get more complicated later on. So I'm going to give you all, let's say about, 15 minutes or 10 minutes, okay, to set up your Google Colab or your environment, your coding environment. And I want you to do what I did here, which is first to define the training function, then define the testing function, then define the, where is it? Distortion, yeah, here, distortion pattern function. Okay, yeah, here we go. If you see the left, the table of contents, set up these 1, 2, and 3. And also the visualizations, okay? All right, set it up however way you want it. You can copy mine, or if you feel better you have a more efficient way of doing it than me, please go ahead and then please share with us later, okay? All right, so I'll give you about 10-15 minutes, let's say 9:45, 15 minutes, okay, to set up these first few parts in your own environment. And then after that, I'll ask everyone to share their screen and show us your instance, okay? Oh, and as you're doing it, if you have questions as you are doing it, please feel free. I'm right here, and you can just raise your hand and ask if you're stuck. Okay, so it's 9:45. How's everyone? It doesn't matter where you're at. Let's go around and share, let's so everyone can see, like, oh, different people are at different stages, like where you've done up to. Okay, can I have everyone maybe go one round? Let's start. Let's start there. Okay, can you connect your screen and then I see if I can share. 那个是这个 ，so let me see 啊，应该是这个。I'll just share with us what you've done up to, and等一下哦。Let me do it again. 它有时候迟钝。Okay, I think we see something. 等一下啊 and this one. 就用这个好了。Okay.
So I set this function, phi function here, and and now I just run once. Yeah, I think I'll
And
run
so you,
every time.
you've done it once.
Just once.
So this is the result of just one time, right?
Yeah.
Okay.
Yeah.
And, okay.
Yeah. That's.
Okay, you've done up to here.
Oh.
Okay, pretty good. All right. Me share another person. Same thing, exactly the same thing, or you have a different solution or different way?
Okay. No, I stuck in the previous stop, so.
You want to switch over your screen? 就拔出来切过去就可以了。
I literally had like zero progress for now because
it's okay.
I don't know why, but the hemi distance is always 8. So
always 8.
Yeah, and it seems like the update function was somewhere wrong, so I was checking this.
Okay. How about before though? Before you got to this, all the other parts are okay?
It's supposed to be, but I'm not sure where it was wrong, so I still working on it.
Okay. Can you show us your like when you set up first the learning rule first? Because hemming distance is at the testing stage, right?
Yeah.
So the training stage, when you train, could you visualize your weights first? Or can we see the weights? You don't have to visualize it as a heat map, but if you type W, you can see some numbers, right? The array. So like, let's say you train once, right? You've trained it once already, right? At least.
You mean just print out the weight function? Oh.
Yeah, correct. Just print out the weight function. See.
So that's
your weights are all 1.
Yeah.
Yeah. So did you train it yet? You have your input, right? You have your A, the A inputs, the wash functions. So print A. Let's see. Make sure that you've got your parts correct. below. So those are the walls functions. Okay, so your A is okay, your inputs are okay,
Yeah.
but this W looks untrained.
Yeah.
So did you train it yet?
I
Try training it one time if you can.
supposed to have, right?
Yeah.
Training.
Is it easy to train it in your setup?
Is the
Okay,
define function,
all right. Now you've trained it, so print it W again. Eh?
See? So define. Oh yeah.
Oh, you just ran. Oh, that was just definition. You have to actually train it, not just set it up. So the definition function, which is this one, you see? Train net Hopfield.
Okay.
Yeah, you copy that and paste that into yours.
I forget this.
Yeah.
Okay.
Paste it as another cell after, where you set up the definition. Yeah, you want to paste that. Yes, that line. So you want to just run that line first, and then you see, okay, good, all right. We have next person.
Well, it is my problem solve.
You want to switch over? Or if people see and you have other questions or you have similar things, please feel free to chip in as well. So it's good, right? So you see, you didn't know that, I just copied the definition, but I'm supposed to have also a running thing, right? Yeah, so that's a common thing as well. Good to pick it up. 可以吗？哦，你需要转贴，这边有，要吗？Okay. Oh, you use the word tokens. Very good. We can talk about that later. What's a token? All right. I see I've avoided using the word token. But it's okay. 对吗？这是你的吧？什么意思？this is your computer, right? 哦，因为你有那个什么 mirror screen 或者什么那个，OK。那你调一下，看你 how do you wanna what you wanna share with everyone? Okay. 好。Yeah, I know I have it. Yeah. But in the class, I never say token. But never mind. We'll talk about token later. Yeah, it's very interesting. Okay.
I just done the question 3A part, and
okay, so you have done the distortion.
yes,
Starting to do the distortion. Okay.
yeah. I defined
but first, the earlier part is okay.
Yes.
Okay. All right. Yeah. So where you at?
I try to use different way. I told AI to do the most efficient way to
absolutely
get the answer, but I'm trying to understand why.
So it did it, but you don't understand it.
Yes.
And how do you know it did it and it works?
What?
How do you know the AI did it and is correct?
I don't know.
Oh, okay. So it did something, there was no error, but you don't know whether it's right or wrong, and you don't understand it yet, and you are trying to figure it out.
Yes.
Okay. Okay, so can you walk us through briefly what are the lines? Yeah. This whole thing is from the AI?
Yes. I told it to give me some Chinese.
可以啊
Yeah.
no problem. 你说什么？请
我是在另外一个聊天室。
or another
对
place. OK，好。
Yeah, I use this function and I told him to give me the Hamming distance iteration.
Each time.
Yeah, and he give me the answer. I'm not
Which
sure.
one is Hamming distance? Mean Hamming distance. So the second column is Hamming distance.
Yes.
Then after that, iterations. And failures 0. Sounds wrong, right? If the Hamming distance is not 0, then the failure must be at least not 0, right? Yeah. Okay, so something suspicious here. We need to go back and check.
Okay.
All right. Is it starting from here? So you're sure that the training and the testing functions are correct? Are you sure that that's correct in the first place? That's the thing.
I think it's just like your code. So.
Well, but did you evaluate that if you print out, like just now when you print it out, when you know visualize it, is it as expected?
Do you mean use word function to?
Yeah, like let's say you train, so you have your training patterns, which are the wash functions here, right?
Yeah.
Okay, then we have the train Hopfield, which is you start with a 0 and then you give it the training patterns.
Yes.
So you expect that if you train this one time and you print the W train, you will get minus.
Yeah, I have told him to present the.
And this is correct.
The function, yeah, it's correct, and I deleted it.
Okay, all right. So you're sure that this training is correct?
Maybe, yes.
As we went through in class, if you did it correctly, it should give you, like mine, the weights, like the minimum should be -4 on the diagonals, right? And then the maximums would be 2 or 1 or whatever, right?
So I should use the heat map to.
You don't have to use the heat map. You can just print W train. It's fine. Yeah, but the number should be like that if you think about it. Okay. So this is good exercise. If at first when we are first trying these small things out, it's manageable to look at the array and the number because you know that it will be -4 or 2 and all that. If it is doing the 2a minus 1, 2a minus 1 each time, right? Obviously, if we are doing a network that is like, wow, 1 billion parameters, 1 million parameters, you cannot look at every number, right? You will get lost. Yeah, then in that case, a heat map or some visualization is critical, okay? All right, yeah. So in this case though, because we are in class and we are learning, I would encourage you to do both. You have the numbers and the heat map, and you can then, it becomes very concrete how you know how to evaluate whether your network is performing as you expect or not. Yeah. So you are sure. That's why I asked. In this case, you can actually be sure because it is mathematically, you can do it by hand, right? So you are sure that the trainnet is working, right? Okay. So then, how about the testing? Oh, how about the distortion? When you run the distortion, is the pattern distorted according to the percentage that you set? Let's say 10%, then it should only be distorted a little bit, right?
So you mean I should present the distortion?
Yeah, I would.
To make sure that it's correct.
Yeah.
Okay.
Yes, I think I would advise you to at least try that, the troubleshooting part first. Okay? Yeah. How about that, right? Okay, so why don't you try that with the distort part, right? Maybe in between these two cells, add one cell to evaluate whether the distort function is working as you expect. because now you're sure that the training is correct. But to test it, you need the distortion. So you want to test whether your distortion is correct first. Then after that, you do the testing. You can see that you have to make sure all these are in place. Yeah. Okay. Why don't you try that next? And then let's go to the next part. Do you have a mic here? Ben, you want to try? Oh, okay. Yeah, okay. Oh, you might need a cable over there. Do you need adapter? 可以 okay. And 这个是这边的。然后可能这个要按那个换那个讯号 to HDMI home， 然后讯号源 HDMI 左下，哎，这个。哎，你点那个啊 ，OK。
Okay.
All right.
So this is the output of my print W, print A.
You trained it how many times?
Like 5 times. Yeah, so
Okay.
that's why. So the heat map's also like
Very steep.
Yeah.
Yeah. Okay.
Looks like it works.
And you train it on the wash rush. Okay. So far all good?
Yeah.
All right. Anything you think misbehaving or not understand or not clear?
No.
All good?
Looks like it all behaved. Yeah.
Okay.
All good.
All right. Then let's go next. William. Okay.
So I'm not that fast, so
Yeah.
I'm now playing around with these functions to make sure I know what they're doing, like say stored. And about training, I discussed with Gemini
Yeah.
a little bit, so now I can. What's glitchy like this? One sec.
接受.
So yes, I can set the approach like.
Oh, so this
kinda
train it
big.
many times.
Yeah.
How many times?
12,
4 times.
like 3 times.
3 times.
Seems too big.
Means you click
for
it
me.
3 times, is it?
Yeah.
Okay. You didn't embed in your script to loop 3 times. Oh no,
No.
you did. So you have n
So
training
these three
epochs, which is 3,
Yeah.
and then you
Approach
have
one,
the W is equals train
Two.
Hopfield net
W,
1
yeah.
time. No, actually that means you train it 4 times because you had line 4,
Oh.
which you executed
Oh.
1 time.
Also, it's 4 times. rather
When
than
you
three.
type 3, actually is 4 because the n training epoch is implemented
Oh.
in line 7.
The first one.
Yeah, but the first line 4
And
already trained it
3
1
forward.
time. So you 3 plus 1, so it's 4.
Oh, okay.
So for epoch in range 1 to 3, train net, and so plus the first time in run 4, so actually it's 4 times.
Yeah,
And
but
then you
these
visualize,
seems
okay.
Too big.
All right. Why did you want to train it so many times? Why did you want to have this loop? I guess, okay, yeah, eventually you will need it.
Yeah.
So you're setting this up for that, okay. All right, does this make sense to you, what it's doing?
I'm not sure, to be honest.
Okay, which part is the not what
I
you're not
may
clear?
need some more time.
Okay, but I think this is more of the control loop, the outside, right? You're looping it 3 times
Yes.
and all that. But do you know what the train net Hopfield inside is doing? That's the more important thing.
Let's see.
That should be higher
got
up.
this.
Define training
Not yet.
function above. No, this input.
Yeah, one sec.
Anything higher?
How can I?
Higher. Higher.
This is distortion.
Even more higher.
Plotting,
You should be the.
weight.
Nope, this testing. Higher. This one. Yeah. Okay. Do you understand this one? Do people understand this one?
Mostly, I would say mostly.
Okay. This is what we were talking about, all the theory, all the part, right? It was the 2a minus 1, 2a minus 1. And it's the Hebbian learning rule,
Yeah.
basically,
D
in a
plus
binary
D plus
sense.
CW, yeah.
Yeah, binary Hebbian learning. Okay, so this is the heart of it, the core of it. So if you understand this, then the train net Hopfield is what it's doing. And so then it's only that you're looping it like 3-4 times, that's all. Yeah?
Yeah.
Make sense? Okay. All right, so you need to spend a bit more time. I mean,
Yeah,
it looks like you've got it, but then maybe you need to familiarize with it a little bit more. Is that
Yes.
right? Okay.
Totally.
All right. Three. Huh? Oh, you need an adapter? Over there is the adapter. 那个切换那个其实 I don't know if we have more adapter， 不可能只有一个。好像真的只有一个。没关系。这边是有一个 USB to HDMI 的 ，if you want it，if you need， 有吗？不是，没关系。Okay.
Yes,
All right. What do you have?
Here I training the fine time, but look like so dark.
You train it
And
5 times. Is
yes,
that 5
5
times?
times.
Okay, yeah.
Yeah.
All right.
And I give the pattern 3, and this shoulder is little point fine, and I see it's like the distance 8, and they
Yeah.
like decline.
Okay.
Not a bit different.
Okay. Did you try different levels of distortion? Let's say you are now at 50% distortion.
Yes, I tried like the 0.5. They will.
Maybe 0.1. Right.
Yes.
See how it goes.
They like the sense.
Try
maybe,
try
but
again.
Try them more time.
Yeah, try a few times.
They will change like the distance will get
Yeah.
close a little
Right.
more easy.
Very good.
Yeah.
Do you understand what's happening here?
Yes.
This sequence of what you are doing makes sense?
Just training and get the weight
Yeah.
and to training to test like if it get the noise, they can close the training
Yeah.
the weighting.
Yeah.
Yeah.
Yeah. So all of you have more or less gotten to these weights, and then maybe this distortion some people are still working on. But once you get here, the next part of which is question 3, assignment 1, question 3 will need you to use this thing but loop it. Okay? So maybe in the next 10 to 15 minutes, we see for those who can get to the distortion part, and then if you're okay with the distortion part, see if you can loop, like, for one setting, you use this code to loop it maybe like 2 or 3 times. So that you see, because just now you press it, at first was having distance was 8. Then you try it again, it became 0, right? So obviously every time it flips. So you want to have it in a loop, see if you can know how to do the code to loop it 3 times. So you don't have to click 3 times. Otherwise you'll be clicking a lot. 72 times according to the assignment. You want to click 72 times, and every time you change, that's not going to work. Have it in your code so that you can loop it automatically. All right, so maybe let's spend the next 15 minutes working through that. And 顺便 we can have a break. So I think we come back at around, now it's 10:10, 10:25. Okay, and we have people work through the route, and so the next round we talk about how we loop through the different distortion levels and see the Hamming distances each time. Okay, all right. Okay, so just to make it clear, have the distortions functions set up so that you can do distorting with 0 probability to 0.5 probability like this, okay? 10% each time. And then run each training pattern in each probability condition thrice. Let's do like 0.1 first. Let's take it a step at a time. Let's do 0.1 probability for each of the 4 training patterns. Each one do 3 times. Test it 3 times. Okay, so just for the next round, we want to share with people that you have distorted the pattern at 10% and you have run each of the 4 patterns 3 times. So that will be 12 Hamming distances, correct? Okay, so the next, after at 10:25, let's see 12 Hamming distances and see what it looks like, okay? All right. Yeah, and feel free to, take a break and whatever. We'll come back at about 10:25 or so, okay? Train net 不是 test. So what this means is you train the W one time only. 所以你的 weights 会是 range from -4 to 2 only. 好，不是说 train until like -12， 那就是 train 了4次了这样子。Train W one time. Then do the test net 3 times. So that's why here you say 6 probability condition. Let's pick one first. Let's say 10%. Okay. So you have 4 different wash functions, right? 4 different test patterns. Each one distort it 10%, right? And then test. So you distort pattern 1 10% one time, distort one time. Then you run the test net 3 times. And each time gives you a Hamming distance, right? So you record 3 Hamming distances for the first pattern that is distorted at 10%. Then you go to the next pattern, distort that 10%, then test it 3 times, 3 more Hamming distance. 这样可以吗？可以啊。Okay. And before we leave today, remind me to talk about tokens. Okay, it's very easy for me to forget, but I think it's important, and I think it's very interesting also. $12? What do you mean? You mean that you will have 12 Hamming distances? Yeah. So right now in class, I don't want you to do 72 simulations yet. I want you to do just 12. Oh, okay. If you did 72, then just pick the first 12. Or, yeah, if you are already very, you're already coded. Obviously, when you code something, you can just do the whole thing. Yeah. No, but because different people might be at different levels. I'm just, for the sake of in class, I want you to pick the 10% distortion only. Okay, so just don't do the others yet. Just do 10% first. And because it's only one probability condition, then it's 4 training patterns times 3 per pattern is 12. Yeah. If you have done 72, which means just repeating it over 6 probability patterns, great. Obviously, you can do that. Okay, but yeah. Actually, why don't you just, are you connected? Yeah. 讯号源要选。你要点那个，Okay. Yes. So each time you run, you will get, if you use my code that way, you will get all this, right? I will have to say it's not efficient because it reports everything. Yeah, you can organize it better so that you get the information you want. Okay, you see how your Hamming distance is always 8, is it? Or always the same? 0. It will always be 0. Yeah. That doesn't look like just 0.1 distortion. It's all close to 0, or not so bad, right? So you have the logic. The more you distort, the worse the Hamming distance will be, right? So maybe you want to go and check, because it looks like it's working, but I don't know, feels a bit weird. Okay, so that's why I said choose one first. Okay, yeah, I know you can always loop and just do the whole thing, right? Sure, but let's come back and make sure we are getting things right. Yeah. Okay. So I feel like something is off. I'm not sure. Yeah, but it doesn't feel comfortable. Yeah. Okay. But that's what I mean. Yes. So like you pick each probability level and you run it 3 times each. Oops. And then after that you evaluate whether it's the Hamming distances are changing as you expect, which means that it's getting worse and worse the more you distort. Yeah, and you would think, why do I have to run it 3 times? It's not going to be the same, because remember the testnet has a random selection function, right? Yeah, so actually every time you test, even though you train the network 1 time, every time you test it, the output has a probability of being different. Okay? So that's why you have to do it 3 times, at least. Yeah. Yeah, question? Yeah. OK， 可以吗？ Let's flash it back. Yeah, let's go around and share about the distortion and training 3 times. 诶，这有没有 ？OK， and then that one 是那个这个。诶，你每次拔掉它就会跳回去那样子的啊？你每次拔掉它就会要跳那个 screen， 那个选。OK， 好，好吧。Yeah, microphone. Yep.
Oh,
Yeah.
here I said 2 for loop.
Okay. So the first one is pattern.
Yeah. And so here, range 4
Yeah. Okay.
now.
And then each
And
time.
I modify this to 1000 to 30.
Yes.
Yeah.
Because the assignment asks you to
Yeah.
set it at 30 iterations, correct?
Right.
Yeah.
And but I have a question.
Yes. Go ahead.
So I have there are 12 this time.
That's not
Yeah.
right.
yeah.
Okay. So what happened?
I still figured it out.
So well, when you ran it one time, was it okay?
When I run
Yeah, if you run it one time, 那个原本的 like in the beginning, when you ran it only, when you click it, did it also give you like a Hamming distance as a vector? There's an error here. Indent， 因为它被 indent， 你要把它 unindent， 对对，那个 print 也是。还是有多一个 indent 是吗？很烦的，对。Okay. Well, it's okay 啊。This is a scalar.
Yeah.
So it's a scalar here, but somehow when you brought it over, it became a vector.
Yeah.
So, yeah, you might need to check. This means that the base is correct, but maybe when you brought it to your loop, maybe some of the indexing or something is a bug, right? So it's not the functions that are the problem. It's your looping, maybe something like that. Can you go back to your loop? Let's take a see. Let's take a look at the looping thing that you did again, which is pattern 4 times in 3. It's weird, right?
Yeah.
Having distance between some absolute AT. Okay, it could be. So this might, I don't know if people have similar problems. Again, remember when I said that Python has this thing where if you make the variable equals to something, it doesn't replace it. It just indexes it. So for example, it could be, I'm not sure, okay? Maybe AT is not replacing a new AT. AT is modifying some original AT or something. That's one possibility. Or here's what you can do is how would you troubleshoot? What do you think? Here's my suggestion. Okay, this one looks correct, right? It is input pattern 0, correct? This distortion looks correct. This looks weird. Look,
Yeah.
the output looks weird. Which is, if its output is AT, right? So something's up with your AT. Right? Correct? Look, can you scroll down? Your AT is always the same.
Oh.
Yeah.
Why?
Okay.
Root. Go up. Loop.
What do you mean? Can anyone see? I can't see it. You mean like the AT here? It's in the loop, right? Isn't it? It's in the 4 times in range 3 loop, which seems correct. Critically, it's like this AT is reported as like always 1. So it's like her test, something in your test net is always giving AT is 1, 1, 1, 1, 1. Is your test net like my test net, or did you make it yourself?
Your test.
Mine.
Yeah.
So can we go back again? Let's say test it 1 time again without the loops. Yeah. Me too. Faster way is you copy that line, but you put a new cell. 不用每次都换来换去，不然就会很麻烦，对不对？Yeah. When you do a test, just create a new cell above it. 对了，一个也可以。Yeah. There will be indentation. Yeah. Okay, let's just try it once. So when you do it once, there's a problem. So you want to set the AP. Is the W a problem? Maybe visualize the current W. So don't need to train. Comment the training line, but just visualize it, the current W. 所以只需要那个 visualize 那一行。对。前面再 comment out 对，然后 play 这个。Okay, looks alright. So the W is okay. Looks a bit weird. 你可能 train 了几次了，是不是？
可是我只just train once.
那为什么有3在里面？你看一下。然后这个是什么号码？
这个是
-3. Something's up. It should be -4, right?
-4?
Yeah. 因为你有4个 pattern， 你圈一次，应该是-4是一个，对，不可能有3。Okay, go back troubleshoot. Let's go to the next person. Okay.
I think I got it.
Okay.
Correct. Yeah, I figured the problem I did.
Okay, good.
I forgot to update the weight function for each loop.
Forgot to update the weight for each loop. Let me see.
So anyway, this is the result.
Looks better. Yeah, Hamming distance is 0, and then
So when
and if it's messed up, it becomes 8. Yeah.
yeah, so when the probability
No.
is higher, the Hamming distance is larger.
Correct.
And for each.
Nice. Okay.
Yeah.
Okay.
So I think that's the.
It will jump around. It's not so obvious when you use your human eye to see, right? But
Yeah.
you can see some trend in there. So what was the error or what was the problem?
So the problem is I forgot to put this one in the loop.
Oh, you need to test.
Yeah.
You mean you need to do? Okay. All right.
So that's the reason why I always got the same output.
Your output was always the same thing. It wasn't actually testing it.
Yeah, it
or
was.
running.
It
Okay.
was a constant.
Okay. All right. So, and this one, the assignment asked you to do 30 iterations, not 1,000. But feel free to do 1,000, and then
Okay.
you just pick the first 30 or whatever, right?
Well, it's still like
Sure,
2 seconds.
Sure.
So
Sure.
anyway.
Yeah. It's very fast. I know. Well, when I was running it in my like tiny computer 20 years ago, it wasn't 2 seconds. Okay. But
Okay.
yes. Nowadays, computer nowadays are really too powerful. Okay, so this is great. So you've sorted it out. My advice though is that instead of having that visualization, because you want to have find a way where, because we asked you to do 72 altogether,
Yeah.
right? Where you have more probability, find a way to plot the Hamming distance as a
Oh.
function of the probability. It's a statistical thing already, right?
Yeah,
You
yeah.
have probability level, and because Hamming distance is 3, you get mean Hamming distance and error, right?
Mm-hmm.
See, to do that as a visualizer, because you will need it later on,
Okay.
something like that. And you can actually do statistics.
Yeah.
Is there a main effect of distortion, something like that, on Hamming distance, correct?
Yeah. But the logic is that the higher probability to distort, the longer Hamming distance.
Correct.
Right. Yeah. Okay.
Correct. Yeah,
Mhm.
absolutely. So you get the sense here. We think that if you distort the probe, like the further the probe is from the original item, then the trace will be, worse, right? It will be not matching as much.
Mm-hmm.
Yeah.
So I do this now.
Yeah, try that. Okay. So for you,
Okay.
try to do 72 of it.
Okay.
The different, organize your code so that you can have a table or a bar plot or some line plot of the increase in the Hamming distances on average as distortion increases.
Mm.
Okay. In other words, summarize the 72 data points that you're gonna have.
Okay.
Correct.
I
try-
will try.
Try that.
I will
yeah.
try.
Okay. So swap over. Oh, 那个 adapter. Yeah. Really, if we need the AI, please switch over to that computer, 然后 AI 马上就切过去，不用切线切来切去。你现在应该可以做了，不用等 few years 吧 ，right？ 这个真的是你想，其实是可以的。Okay, where are we at?
Okay. I think 1 minute ago my problem is that the distortion pattern don't change, but I think I figured it out.
Great.
Yeah.
What did you find?
Uh,
What was the
just
reason?
correct the just some names.
Okay,
yeah.
so it's just your naming thing.
yeah.
All right, great.
Yeah.
Okay.
And the
And is it
12
behaving?
trial result is here.
Okay. And this distortion is, I can't see the distortion level. I mean, I can see the distorted pattern, but
Yeah.
did you have like what is the level of distortion each
What
time
is the level of distortion?
in the output?
No, I didn't.
No, okay. So you might want to do that so that it's easier to, so that we know that this is what distortion pattern. Is it 10%? Is this 10%?
Yeah, 10.
Yeah, so maybe put like, 10, Yeah, so for the, the others also, yeah. If you have an output, it might be helpful for you to organize it so that you can use it later for some analysis.
Okay.
Okay, so is it behaving as you expect?
Yeah.
In the Hamming distance is now, like as you distort more, it gets worse and worse, more or less?
Yes.
Yeah, okay. So you satisfied? Okay. You think you understand the AI?
I'm not sure if this, the
Yeah.
index of time error and fail can make sure that my previous step doesn't do wrong.
What is time again?
The trial that it make it to the final result.
Oh, but we asked the iteration to be 30.
Oh,
We cap it at 30. The assignment asks you to cap it at 30. Is it
so I need
taking
to-
so long to settle, really?
uh,
It should settle pretty fast.
Okay, so I need to add the limit of 30 trials.
Do you have it? Let me see.
I think
In the
maybe
code, there should be. What is your current limit now? I guess. Let me check.
Maybe
No, you put it at 30, right?
Yes.
So what's the time thing? If you cap it at 30, all this. So unless what's this variable? I guess I'm not sure what this variable is.
Uh,
What's time?
okay, I will make sure.
Okay, yeah, go and check it because, oh no, 30 is the number of, total runs or epochs to run, but it might have different iterations to settle. So just make sure that you've got the 30 correct. Okay, and then yes, mean iterations. All this is something you want to record as well. So you can see like if your probability is 10%, this is the performance. If you increase it to 20, 30, 40%, see if it's getting worse and worse. Okay, you want to give it a try? Okay, so that would be the next step. If you think that this is satisfied, yeah, so you have 12 here, Hamming distances. Yeah, you want to make sure the the labels are correct. So is this Hamming this? No, this is pattern. Hamming, this might be Hamming distance. Is that right? No. Okay, it's important, go back and check. Okay, and make sure you use the same labels because the assignment asks you based on that labels. So if assignment asks you for Hamming distance, don't call it error, call it Hamming distance. I mean, assuming it is Hamming distance. Okay, yeah, that way you don't confuse yourself also because you're using different labels. You see, this is Hamming distance, right? And you're using different labels when you transfer it to the data frame. Make sure you tie all these labels and variables down. Okay, so almost there, look at it, and then it looks like you're getting there, so, okay? All right, so yeah, so for those, the next step is to do the 72 simulations. So you get 72, right, values, and then plot it out as like a statistical report, like a table or a graph. And the expectation is that the Hamming distances or the performances will get worse and worse as you distort more and more, right? Okay, yeah, so that would be the next step for you guys. And next is over here. Hey. 不对，我应该切过去，是我，我没有贴。那这样共享分享，来，的讯号，对，then HDMI。 要按那个上面。Okay.
And here I use the pattern 3 and I try the
Sure.
6 probability and do the for loop, and they show out the each time they just like recall the noise 0 and 0 runs 3 times, and they can settle and can see the distance is 0, but when the distort is more bigger,
Yeah.
is bigger, then the distance will be more higher.
Okay.
High. So I just do the figure.
Oh,
to
so you
show
already
out.
have this. Great. So
Yeah.
yeah, so this is an example, what I mean, right? You all can have the different noise level and then the mean Hamming distance. Okay.
Yes, will be more high. And I
Yeah.
choose the one, the pretty, to show out the figure about the energy. They will decline also.
Yeah. This one is for one trial.
Yes, because I choose the pattern 3 and
Ah,
noise 0.1.
only one, okay.
Yes.
Yeah.
I just see the above the figure table to choose one to show out.
So I think the assignment asks you also on each run. So if I split, give me a second here. Huh? Okay. So you see here in part A is the Hamming distance between the final and original, which you all have. The number of iterations it has to run before settling, which means the number of iterations it reach before the Hamming distance doesn't change anymore, okay? And the energy of each iteration. So these three things, okay? So if we go back to yours, you have the Hamming distance there, okay? Yeah, Hamming distance there. But you want to also record or report the energy or the iteration, the number of times it takes to reach when the energy doesn't change anymore. So like you have to see this number is what,
Okay.
okay? And also the energy, obviously. In this case, the energy is minus 96, yeah, 97, minus 97, something like that. Okay, so beyond just the Hamming distance, which you plot, see you can add the energy and the iteration to settle. Okay? Yeah, so that's what the assignment wants you to do. Okay?
Okay.
All right. Next, William. Oh, well, switch to Benjamin. That's fine. He's very deep in it, so you don't want to break his thought. All right.
So this is the thing with making each iteration probabilities, and then
Yep.
yeah. So it's like this is the output.
Okay.
Patterns, Hamming distance, iterations to settle, and then down here is the energy change. And I want to know how much it changed.
Right.
And then this is for the one with the most change. I don't know.
Out of the three? Of each or
of
of
everything.
total?
Of
Okay.
total. This is everything that had change, and this is the one out of that had the most change.
Okay.
And then yeah, the average final Hamming distance for each.
Very nice.
Out of the total of the three, or the mean of the 3 runs. Yeah.
Okay. Right. So is it behaving as you expect?
Yeah.
So more distorted, basically takes longer, more errors, etc.
Pretty much.
Okay.
Yeah.
All right. Okay, very nice. So do you have, and since Benjamin had the energy also as a record, right? You can see. Okay, so if we go back again, and I wanted to highlight this. So remember we talked about what is energy is the minus half, then the weights, and then AIAJ, the product of it, right? Which we talked about is akin to the kinetic energy, okay? So this is actually what it means when we say like the Hopfield network is an attractor also, because what it is after you have trained it on 4 states, effectively you have created 4 you can think of it as 4 gravity wells, right? So this is state 1, state 2, state 3, state 4, and they are like attractor states on a kind of a plane, okay? And when you put a probe, which you distort, if your probe is exactly on one of the 4, it will just drop directly into the one of the 4 wells, correct? But if your probe is like somewhere is distorted. Distorted means you have 4 wells, but it is located not exactly on the wells, maybe to the side, maybe far away, maybe just right in the center of the 4 wells. Then in order for the probe to drop into one particular location, it has to move further, right? Or it has to move around back and forth before it finally settles on. So there's more kinetic energy invested or happening. So that's what the energy means, and you can see that that's what's happening, right? The more distorted you are, the further you are away from either one of the 4 wells, and so you need more kinetic energy, or you expend more kinetic energy to settle onto some state. So that's what's happening. That's why it's called attractor network as well. Okay, all right, very good. Okay, so that would be Ben's one, and then William, you ready? Okay.
We're getting somewhere. So in
Okay.
distortion 0.3
Yeah.
and 10. If I'm trying 30s. So
Yeah.
start from 0 seems legit.
Yeah.
But let's see. 8, 5.
So what's the distortion level again? 0.3?
Yes.
Okay.
Start from pattern 1, but it's doing a.
Okay. I mean 0.3 is decent distortion. So you will not
But
you
它时好时坏 I kind of
yeah.
don't know why.
That's expected.
Uh-huh.
I mean, why don't you try distortion 0.1 first?
0.1. It should be better in.
Yeah, you will expect it to be
0.1.
better, right? So try it and then you see if it is indeed better.
Start from yes.
Uh-huh.
Correct.
0.
0, 0.
It's statistical.
9.
Yeah, it happens. But then you compare it with the distortion that you imposed, right?
Oh.
Okay, but I want to caution, check first whether you are doing it, your looping, is it correct?
Yeah.
We distort the patterns for each one only once,
Yes.
but then we test it 3 times. So make sure, so we train the network once,
Mm-hmm.
okay? Then each pattern we distort once. But
Yes.
then we test each pattern, distorted pattern 3 times.
3 times. Yeah.
Okay?
So,
So make sure you are not like train one
distort,
time,
test, distort.
distort one time, test, and then train again, and then distort, and then test, right? And then do this 72 times. Make sure that you train once, distort once for each probability and each pattern, but
Only
each time
once.
only one time distortion applied. But then the testing is 3 times each time.
Okay.
Okay, so make sure your loop is, because I can't tell. I mean, it looks like it's okay, but I can't tell. But it is something that you want to watch out for just in case.
It should be distorted only once.
Yes. And
Is
then
it-
test 3 times.
Oh. Oh,
Train
sec.
once, distort once, and
Train
test
once,
3 times.
Distort once. Okay. 1 sec.
Yeah, so it looks like you've trained it once here, assuming we start from nothing, right? So you've trained it only once,
Yeah.
and then you want to distort.
Distort is right here.
Oh,
Distort
okay, you do the
before.
distort before. So you only distort once.
Yes.
For one pattern,
Yes.
and then
One
you
pattern
test it 3 times. You have to test it 3 times. Probably range is should be
Here.
training epochs.
is
Why your training approx is 10?
that's too much.
What
yeah.
does that mean? Oh, okay.
So start from
All right. Yeah.
times 4, 5. It is only twice, so I have to.
No,
set-
because you start from 1, so you need to do 0 and
0 to.
oh, you can do 4, sure. Yeah. Get used to the Python indexing.
It
That's
starts
right.
from 0, yeah.
Correct. It's
Oh.
very confusing from MATLAB person.
Mm.
Okay? All right, looks like you've got it there, but you got to make sure you figure it out, like the looping and the iteration.
Okay.
Okay? And then, like we said just now, the idea here is for each time you want to take out the Hamming distance, the number of iterations to settle, and the energy. Okay? The final energy. Okay? So these 3 things. And then you plot it as a table, and you should have total 72 rows. Right?
Yes.
Because
70
it's
lines. Yeah.
4 patterns, 6 distortions, and 3 3 trials. Yeah. So 72.
Okay.
Okay? 可以吗?
We're
Any
getting
questions?
somewhere. We're getting somewhere.
Okay. All right. We'll just let you continue working at it, and that's 1 round. 那刚刚还有问题的还可以吗？你 debug 了吗？还是 still debugging? Okay. So then maybe give you about maybe 10 more minutes to do the debugging, okay? Or 有要分享，然后我们可以一起 debug 吗？还要？还是你要自己想？都可以。好。可以看一下，你可以分享啊，荧幕。For the rest of you, if you want to, if you have got your table set up, then you can move on to question 4. Change the input to these 4 patterns and do the same thing as above. Okay? All right? If you've more or less stabilized for the up to question 3, then now you can do 4 and 5. All right? Okay, then let's see what's your debugging here. 这个是什么? Right. Okay, 10%. So 刚刚你的 AT 都意思是不是那个对的 AT? Okay, then 没有啊，这样我们下面再下面一点。The true value of an array with more than one element is ambiguous. 你有换那个 distortion pattern 吗 ？The code， 这个感觉好像你有去改了那个 distort pattern 的 code 的感觉。哦，没有，是你把 input 改了是吗？OK, so 等一下，我先搞清楚，你可以 visualize 你的 W 吗？可能在上面先，对，我们看一下。OK, 所以 -4 了哈。OK, 所以对了，input A 是那个4个 wash function。OK, 然后 W 是这个，然后 OK 好，所以你跑了一次 W 对不对 ？OK, 现在是在用这个 W and 这个 A。好，那我们看 distortion。你把它拉下来 ，so 你 set distortion 等于0.1。So for pattern number in the shape dimension A dimension A 的 dimension，然后 test pattern 等于 pattern number. OK， 你就 print pattern 等于0，然后 AP 等于 distort pattern A。OK， 这个是一个问题，因为你把 test pattern number 等于一个 array of 一个 number， 这个是一个 number， 你把 number 放在一个 array， 一个 or 一个这个是什么 list or whatever， 所以你这个输入 A of a list of a list， 所以你这个你其实不用这一行嘛，你就直接 pass pattern number 这边就可以了，你不用这个，你不用这一行，直接 pattern number， 试一试。不是，这个要 pattern， 这个不能 test。OK， 好，对，所以那个问题还，等一下。你现在 distortion 是 10%，OK，so 你看一下这个 input 跟 distort 有没有对，有没有，所以 10% 的感觉，好像是有了哈。OK， 感觉好了，是吗？Output。output。OK， 可是你的 Hamming distance 还是一个怪怪的 vector，right？ OK，so let's go back to 上面的 Hamming distance 的这个部分。again 就不要 test， 对，try that，OK， 好了。这是讨厌的 bug， 就是这种。OK，so evaluate it, try it now at different distortion level， 然后看有没有符合。OK，alright。So 那些如果 OK 的 then if we jump back, just as I said, you can busy yourself with question 4 and 5. 4 and 5. So train, those of you who have set it up, train on this. And the same thing, test, create the same distortion test patterns and run each one 3 times and get the same energy, Hamming distance, number of iterations tables and compare. And if you've plotted a line for the previous one, right? 就是你有那个 distortion level， 然后 Hamming distance 的那个 bar graph 或那条线，你现在可以比较2个 ，right？ 你就会有上面的那一条线跟这一次的第2条线， so you have 2 lines, and you can run a statistical ANOVA or t-test, blah blah blah, right? So try now. If 你这个成功了。It's easy for you to move before you go to question 6. You can plot a plot with 2 lines. 一个是上面的那个 Hamming distance change and energy and iteration, and 然后加上多一条线是这一次的 Hamming distance, energy 跟 iteration. 然后我们可以比较这2个的差异。Okay? Let's take about 10 minutes on that. Okay, so 11:20, we'll go again. Okay, 11:20，可以吗？ If you have set up your thing, your code nicely for question 3 already, it shouldn't be hard to jump to question 4 and 5. You just have to change the input, right? And then reset the W, okay? Remember, your W has to be reset. Don't use the W you had from question 3 and then like implement it here, right? It will be weird. Or, I mean, it will work, but it wouldn't be what we are trying to do here. Here, what it means is change your A input to this ones instead of the original wash functions. And then train a new W on these ones and then do the same thing. Okay? Do people have that? We go one round and then see where we are at? Or 还没？可以吗？ Okay, then let's go one round and then see if you have what you have there. Let's go. 可以吗？要不要切过去？等一下啊，这边。Yeah, you'll find that once you set up the first part, the rest are quite easy to just manipulate. Hopefully. Okay, good. Yep. 对, so B array sure. 这样. Yes. Yeah. 诶，要用麦克风，不然听不到你。诶，有吗？哦，这里。
I'm also curious about how to record energy. And I try put one line here.
Yes.
In question 3 here.
Yes.
And the output is like this. And I still try to figure out what it means.
Correct. Because E is a you can see here, it's a kind of a array. It's not a NumPy array. It's just a normal Python array, which is in a way kind of like a list. Okay, but inside are different float numbers. Okay, so you want to print it out. You can ask AI now. So I want to print E as a string or a normal number. How do I do that, right? And the AI should be able. So this is just formatting issue. So E is correct. Inside the information is correct, but you just want to see what function I have to say print E as a integer or something like that.
Okay.
Yeah.
Okay.
Does that make sense? Okay.
Okay.
Right.
I'll try.
Yep. Okay, next person.
I haven't finished 4 and 5. I'm on the way, but
Sure.
I finished the third question in question 3.
Okay. So you have a full summary table or some sort of summary?
A graph.
A graph, great.
Sorry.
Very nice. Okay.
There. Oh, give me a second. My computer is also very slow.
Oh, is it?
Here.
Yeah, okay. Yes.
Yeah.
Right, okay. So you can see that it gets worse, average. Okay. With average, always never forget, if you have an average, you should have standard deviation, right? Or standard error. So try to see if you can also, ask AI to help you. Like, I want to put error bars in there. How do I do that, right?
Okay.
Okay, yeah. But yes, this is good. So you have this, you have the means, but don't forget, you also have the errors. It's important because you also want to get an appreciation of the model stability.
Yeah, I know it's the standard to.
Correct. Yeah. All right. So this is good. Anything else?
No, I'm just still working on question 4.
Okay.
I'm on the way. Yeah.
So if you've got that
almost-
set up, it shouldn't be hard because as you see, it's just changing the input.
Yeah, I know.
Yeah.
So I was asking AI to do it for me.
Very. Yes. I think also, yeah, to reflect on this, right, is if you are confident in already what you do, then when you ask AI and you know AI gives you something, you are in a better position to validate whether the AI is behaving or not, right?
Yeah.
Yeah. So, okay, great. Should we
Okay.
go next person? Oh, finish what? What is this? Oh, okay. Yeah, so then plot it out also. So see if you can visualize it and then compare the two. Compare the performance of the network when you use question 3's training and inputs, and compare that to question 4's performance. Okay.
Okay. Sure.
Yeah. And you can think about it too. Why are the two different? It's just input that changed. And the input changed in that way. Okay. So this is the new
Yeah,
new input.
New
Yes.
input, and make sure that it is
Very good.
correct.
Yep.
And I just finished the
the
12
testing?
result.
Okay.
I define probability as 0.1.
10%. Okay.
Yeah, 10%. And I'm
Yes.
trying to make sure that the distortion is okay. But
This looks like it's not this. Oh no, there is. This one is distorted.
yeah.
This one it's very lucky it didn't distort anything.
Yeah.
But yeah.
Okay, that's all.
Okay. So similarly, you want to extract the information you want so that you can plot the table or the graph, and then you can compare the two, question 3 and question 4. Okay? All right. Any issues? No? Better? You get what's going on now, right, with the AI? Great. Okay, let's move on to over this side. Ben, you ready? You want to? Then I switch over to this side.
Okay, so this is the original one, and this was the one in the question, and this was one I wrote, randomly made one myself.
Okay.
And then, yeah, so right now it's showing this one.
Yeah.
And then, yeah, so that's how it looks. And
Okay.
then here,
How is it performing?
similar.
Similar?
Like it gets worse the more
Oh,
distortion there
okay.
is, yeah.
Okay.
Yeah, so iterations to settle, and
Are you able to compare the two, like side by side or on top of each other? Are you able to compare the performances based on the different inputs side by side? So, for example, like you get a mean Hamming distance from the question 3. Can you compare it to the mean Hamming distance from question 4, or a mean Hamming distance from the one that you tried yourself?
okay. I didn't do that, but I can.
Oh, okay.
add it.
Well, you have the table, you have the information.
Yeah.
So see if you can visualize it all together. You might
okay.
see very interesting patterns.
Okay.
Okay.
Yeah, I just.
Well, you have something, isn't that it?
No, I asked AI to do a table just for the.
Oh, just for the different patterns.
Yeah,
Sure.
yeah.
But you want to more of the different
Inputs.
input
too.
sets. Yeah.
Mhm.
Sure. You will have different patterns, but you want to summarize this and then compare across sets of patterns.
Okay.
Okay. By way of just to project, what do you think will happen? At first is the wash functions, then is the second one, okay? And then let's say you have your own. What do you think?
I guess like the wash pattern will have like less distortion maybe, and then mine will be like mine was more random, so it'll be more distorted as it goes on.
Right. Why? Why do you think?
Because the model needs to spend more energy to like try to, I guess, find a match kind of thing.
I would, so think of it also this way. We define wash functions because they are orthogonal, right? Which means that they are not linearly, they are linearly independent of each other, okay? The second one also, question 3 also, they are orthogonal. So effectively what that means is these gravity wells are separated, like completely, right? If you do random, where they are possibly not linearly separable, correct? Then what that means is the gravity wells might be like partially overlapping. Imagine a space where you have a deep gravity well, but then some minor gravity well nearby. So the two gravities sort of distort the local space in a interactive way. So you can drop here, but you might drop here. You know, the performance will be a bit different, as opposed to very separate 4 or different gravity wells, right? Think of it that way. Okay, so think of therefore how the performance will be, right? Yeah. So you're right. You're there. So just think, have a different way of thinking about it. Okay, you want to switch over to William? You ready? Yep. Okay.
1 sec. New array are called array B.
Array BPV. Okay.
Yeah. And of course, after training.
Yeah.
0 at the beginnings. Oh,
The
distortion
different
is,
distortion levels, right?
0.1 to
All right.
0.5. So noticeably the energy is
There we
really
go.
high
Yes.
compared to A.
Okay.
Energy A is about around 400.
Okay. But how's the distribution like? Can you go to A again? Okay. So here you see the so this is interesting. So you know, everyone's gonna have might have a different perspective or discovery. So William, you see yours is this is with the wash functions, right?
Yes.
Original. Compare it with the second set.
Compared to B.
You're seeing something interesting. What is happening? Right? You obviously you must be seeing something, right? That's different from the first one, right? Yeah. I don't know what it is, but what do you think is happening? I'm pushing this back to you guys because you guys will be using the model in more creative ways, possibly, right? Than what is requested in the assignments. But don't just use it and then just report. Think about it. What does this mean? Because you are using these models for real and you are seeing these results. What do you think it means? And we compare this with the previous one.
Differences.
What is these sets and what are these sets? You are the one who ran it, so you know.
These
Yeah.
should be 0. Distortion 0.
Okay.
And
what's the second
the
one?
more distortions.
Yeah.
So I guess 0.5 should be around here.
That one? 10%.
Yeah, 10%.
Okay.
Maybe 20.
Is there any reason why here you get a nice separation between 0, 10, and then the rest? And then in your previous one, you see you go back to the earlier one. It doesn't. You didn't do the 0 here.
Oh yeah.
And your energy is a bit weird because it started at about higher or something.
0. I did 0 here. Oh, 0 should be around here.
Yeah.
But they are mixed. Kind
Yeah.
of mixed.
Yeah. Interesting. And your energy is starting at 300. That's not normal. I think your weights, you need to check your weights. Whether you were training the weights, as we said, whether your weights are being trained each time or is it just one time.
It should be start from.
If you visualize the
First.
weights, it should be still just -4 for this one, for the deepest part. It looks like it.
It started
Yeah.
from.
So then
-4.
why is it that the energy is so high at 200? It's a bit weird.
One sec. Yeah. No, I don't know why.
Yeah, might want to go back and check.
Okay, one sec.
Okay. So yeah, so I'm saying is that you guys are gonna use things in a creative way and whatever, but go and check. Don't just plot and then just see it, but be very critical. Okay. So this is good. It's very healthy. Okay, because we might see something interesting, and then it goes back to say, oh, things might change in this way. All right. And it might be meaningful, or it might also reflect something in a bug. We don't know. It's just a modeling world is like that. This weight looks very deep. It looks like you've overtrained it. So this might be why. And it looks like you've trained it each iteration or something. Not sure. Is it? Yes. Yes, you do. You look line 13. No, your line 13. You're training your weight each time. You need to comment this out. Yeah, you have to put it only in the beginning, but it should not be in the testing loop or the distortion loop. Training it 72 times. That's why. Huh? Yeah. That's not technically wrong. I mean, in real life, we train it passively and then we never, if we are tested, doesn't mean that we don't learn when we are tested. When we are tested, we still learn. That's true of biological systems. So it's like you can never not learn. Okay? Biology never not learns. Yeah. You gotta remove line 14. Line 14 cannot be in their loop. Or you can comment it, yeah. Okay. Yeah. And then the weights should always be the same all the time then. That looks alright. Yeah, the weights should always be the same all the time. Because you're not training any new weights. You're just testing each time. Okay. Alright. So then, try it out. Make sure you clean up the code and then try it on B. Yep. Alright, shall we go next? Yes.
Now the two
Yeah.
two
Pattern A and B. Okay.
yes, and here I just use the W and chaining in it and use these two to get the probability for the 6 type and
Yes.
run the 3 times. And just the summarize on like the Hamel distance
Yeah.
and settle
Settling.
and yes, and
Okay.
also they will show out the each time their
Oh, so did you
main-
train one network on A and then continue to train on B? Or is it separate?
continue.
Continue. So it's like your W you train twice? A
Yeah.
first, then B?
Together?
Is that correct?
Yeah.
Oh, you mean once through, but you train it over 8 patterns.
Yeah.
That's what you mean. Okay, so this is going to be slightly different.
Different. Okay.
No. There's nothing wrong here. It's very legitimate, but think of it, okay?
Okay.
I mean, you're doing it in a very exciting way, which is sort of what we will ask you to do later. But actually, for questions 3 and 4, the question only asks you to train first for the wash function for pattern A. Train a W, but only on the pattern A.
Yes.
Then have a new W and train that only on pattern B.
Okay.
Okay, so like you should have 2 Ws.
Okay.
Okay, here you have 1 W which has been trained on A and then B.
Yeah.
Yeah. Later on there will be a question that will ask you to do that, but this is interesting. So yeah, but you know, just so you know that if you want to answer the assignment, this will be wrong.
Okay.
Okay. But the assignment asks you to split it up, okay?
Okay.
Yeah, but as an exercise, actually, it's perfectly fine, right? It's completely makes sense. But you have to be clear about what you're doing. Yeah. Okay. So, but I'm interested. What do you get?
I just do the t-test because I put the plot first to make sure the distance and the setting and the energy. And yes, I do the t-text there too.
Very nice.
And the distance and settle and energy not have the p-value minus.
Yeah, I mean, you know, it's like you just simulate more, your n increase, then maybe your significance will come out or whatever, right? But
yes,
sure.
So I plot the figure, don't see any difference.
Sure.
I think maybe it's this problem.
Well, let's go and see your lines on top. Okay, your plots. Your plots are very interesting. Okay, so everyone can take a look. Do you see an interesting trend? I mean, significance aside, do you see something interesting? Is there a consistent or interesting pattern between A and B? Let's not care about the error bars or the significance. Let's just talk about the trends first. Huh? Sorry? What correlation? Okay. Yeah, so you mean like as the noise increase, they both show the same drop in performance? Right? Okay, yes. And is that expected? It should be, right? This should be like the universal thing. No matter what kind of network you are, if I increase the noise, because theoretically, 0.5 distortion means no information already, theoretically, right? So cannot be that, well, any network will be like at 0.5 can still give you good performance. That would be weird, right? This network is weird. So this is expected. Okay, anything else? So for me, I mean, again, error bars and statistical significance-ish requirements aside, I do see some sort of a trend that B is performing worse than, B is performing worse in terms of the Hamming distance, okay, sort of, but it's settling like faster. Energy is okay, all right, yeah. So that might be interesting thing to think about. Is there any reason to think why it settles faster, but then it's not performing better? This is like what do you call speed accuracy trade-off. 我很快反应，可是我 accuracy 是掉的 ，versus 我花多一点时间，可是我都答对 ，right? Yeah, and it might be something to do with the difference between A and B. Think about the A is a wash function, which is they are orthogonal. But they're orthogonal in a way that is, what's the difference you think between patterns A and B? A is spread out, mirror image, like between, right, one set and one set of units compared to the other set of units. And also note, A has always 8 units on, 8 units off. They are distributed, but always 8 on, 8 off. Okay, for B, it's also orthogonal, but it is 4 on and then 12 off, and it is not so much so-called distributed. But to be careful, okay? The although you see like it's one cluster like that, there's nothing meaningful that they are bunched together, because this is just a arbitrary vector, okay? Actually, if there were only 4 units on here and they are spread out, and they are also 4 units, but like different set of units and spread out, it's exactly the same as this one, effectively. The location, the position is meaningless here. So it's very tricky. Human beings, our eyes are very strong. We look at this and we see, oh no, there's one cluster there, one cluster there, one cluster there. But to a machine, there's nothing special about the clustering. What it picks up is that there are 4 units on here, and they are different for the 4 units that are on here, and they are completely different from the 4 units, completely different from the 4 units here. Okay? So these, absolutely, there are no units that overlap. Okay? And there are 4 of them at any one time. Walsh functions, there is some overlap. Okay? So there might be some interesting difference, but they are always orthogonal. Okay? So think about what that might mean. Okay, but it's interesting for you because you train your network first on the first 4, then after that you train it on the second 4, the same network. Interesting to compare then if you separate it and see is it different. Yeah, make sense? Okay, yeah, pretty cool. Any questions, anyone? So does everyone know how to apply it to the question 4 and 5? What you did in question 3 and then apply it to question 4 and 5? Okay? Okay, yeah? All right. So I'm going to move on to the assignment, in the assignment. So question 6. And Ben, you've done this sort of, right? You've created your own pattern. But here in question 6, we only ask you to do 3. Create 3 training patterns. This time, make it random. And when we say random, we mean that each pattern, this is not distortion, okay? This is creating a new A input set such that there are 3 16-bit words, and each bit of each word has a 50% chance of being a 1 or a 0. Okay? Do you know how to do that? You have your distortion pattern already very easily. You can do that. Or you can just type it, with yourself. Okay? So create 3 input patterns such that they have a 50% chance of being on or off. All right? And it's okay if they are not evenly distributed. All right? It doesn't have to be half. Just whatever it is just make sure that they're random. Okay? And then create test patterns and test these 3 out. That would be question 6 and 7. All right? Do we need to try this? Okay, yeah, let's try this one, okay? Just for practice, because then after that, I think that is it, what time that we have today. And the rest, if you're familiar up to question 7, the rest will expand you a little bit, but you should be able to handle it, okay? So let's take about 10 minutes and try 6 and 7, okay? Which is going to be a new W, okay? So don't use the W you had from question 3 and question 4. Create a new W, right? And a new A, set of A's, and in which this A is 3 patterns, random ones, and train this new W on these 3 patterns and test them as you did above. Okay? And then let's see how the performance is. Okay? Yeah, so let's take 10 minutes to do that, and then we go one round, and that should be pretty good for today. Okay. Shall we go one last round? Check how we do with creating random patterns and training it, and how does this new network do? Should we go around? Let me switch over to that screen. 这边这个可以吗？还没好，有好了吗？或差不多的。3 more minutes. Okay, okay. I get 3 more minutes. Okay, okay. 差不多。No problem, no problem. 还是有谁好的就可以先讲。还没 ？Okay, 那就3 minutes. Ready? Go ahead and connect. Yeah, and then. 我最近是在想 next time I teach this class, I'm gonna make like the last class will be a hackathon thing, and 是一个 competition，所以就会把一个问题放在上面，然后大家就抢谁可以第一得奖啊，第二得奖，blah blah for fun 啊，for fun right？ 那就这样，然后就会很好玩这样子。OK，all right。然后要有奖金啊，当然要好的奖金。第一得奖可能很多钱，还有什么？我会破产。Yeah.
Okay. So back to the question 3, I put the error bar.
Oh, great.
Finally figured out how to
There
do
we
it.
go.
Yeah.
Yes.
And actually just few lines.
Yeah. Yeah.
And for question 4, I this is
okay.
the graph.
Yeah. So in your case, and you have 2 networks separate?
Yeah.
Okay. So in your case, it seems performance is on par. So not like just now. Or what do you think?
What do you mean?
Means like the 2 network performances are equivalent, more or less.
Yeah.
Okay.
Yeah.
Okay. All right. Fair enough to say. Both are orthogonal inputs, right? It's just that wash functions have overlapping unit states, whereas the set B, none of the activities overlap,
Yeah.
right?
Yeah, I set the weight function different.
Yeah, it's a new weight, right? So when you train a network that has been trained on wash functions, and then you test it on those wash functions, seems to perform similarly with a different network that is trained on the completely orthogonal functions when you test it on that, right?
Mm-hmm.
Yeah. Okay. Well, that is your result. Okay.
Okay.
All right.
And for 6 and 7, so
These are the random
yeah, the
ones.
random
All
one.
right.
So anyway,
Okay.
everything is supposed to be the same because it's the same code.
Yes.
And
It looked like there was an error. You go
uh,
up. There's an error. What explain error? What error?
I don't know.
Okay. Well, I don't know. You have to look at it and make sure there was no error. Right? But in any case,
But I think the result looks
Okay.
Oh wait, no, not okay. I know. I know the reason.
Ah.
So this is supposed to be.
Okay. A new net. Sure. Okay.
Do I have to change anything?
W is different now, right? Or WC? No, your test net. This one. Yeah, WC. Looks okay. Try. Okay. Any weirdness?
So probability 0, the Hammond distance 1.
Oh, but you shouldn't be distorted. Oh no, this is the input. Oh, okay, so this is the input. This is the distortion.
This is the input. Yeah, this is the input.
This is the input. This is the distortion, which is 0 right now, and then the output has some weirdness.
Yeah.
Okay. Yeah, sure. Do you have a summary? Did you have? Can this be plotted as a line?
But the
Yeah. Yeah.
but the distortion probability is 0, right? So
Yes. So why
the-
is the Hamming distance not 0, right?
Yeah.
Yeah. Why do you think?
Is my code has a problem?
Hmm.
Or
This kind of uncertainty is very hard to be comfortable. I cannot guarantee that the code does not have a problem, right? Unless we sit down and we do it in detail. But remember, the input is now random. They are not orthogonal. Think about it.
oh, I see. So different. So the capacity is not big enough to store like 3.
The capacity is not independent enough to store 3 separate. The things that are being stored are not as separate as originally in sets A and B.
I see.
In set C, the things that are being stored have some overlapping. So I talked about it, right? The gravity well at first is separate. Now you have some gravity well that is overlapping, right? To semantic space, at first you have mammals, reptiles, fish, and plants. Now you have a kind of cat, a different kind of cat, right? And then like tiger, so they are all cats. They're overlapping. They're not completely separate. So that if I give you a cat, you might think that it's a tiger, something like that, right? Okay. Does it make sense? Yeah. So if you plot it out,
And yeah, and
yeah,
there's
you
the
can see similarly some sort of noise issue. Yeah.
yeah.
It's not going to be perfect, right?
Yeah.
But it still follows the noise thing.
Yeah.
So it has some stability as a content addressable memory, right? If we go back again to the original question, this is about content addressable memory. So a machine index will be perfect, even if it's random, correct? You will expect a computer to retrieve exactly the code even if it's random. But content addressable memory will have this, where if it is the data are overlapping, there should be some interference or effect because it's content addressable. Okay, but to the extent that it suffers from the distortion, it should also still perform the same. Like that is influenced in the same way by the distortion.
But if we have like 10 patterns, it will be messed up, right?
So you have the tools, train and see. Try your simulation with 10 random patterns, see how it goes. It's so doable, right? You have your setup now. It's not hard for you to try and then see and think about it, how it goes. And obviously now you have 16-bit words. What if it's 32-bit words? What if it's 64-bit words? What if it's only 4-bit words? Actually, one of the questions would be asking you to do 4-bit words. Okay? So these are great questions, and you have the base. Try and see how you can push it and see what you think about it. Okay?
Okay.
Yep. Next. 没有，不行吗？
Who
还
wants
是
to
是
keep next?
哈？不行。You? Yeah. Why don't you show? Yeah. 你 OK 吗？ Just make sure you're not stuck. 那这边是 switch over to here. 要判那个 screen. Yeah, that's frustrating that it always has to do that. 我们没有办法 keep it. All right.
I set out the 3 randomized aerial, and this time also like setting the weight, but I setting the 3 different way and show out this. And also I just like the visualize
nice.
about
Yeah,
the 3
yeah.
pattern and the weighting.
Yes.
And make sure they have the different ways. And run the simulation, and here you can see the different distance and settle.
Just to check, are you still running one thing but over 16 weights now, 16 patterns now, or you're having 3 different?
3 different patterns.
Okay, all right.
Yes, and also I draw this.
Okay,
this
good.
Kind of the
So
picture.
what do we see here?
I think maybe the distance is not stable because it's like the randomized the pattern.
Yeah.
The energy look like they're increase the more higher when the noise.
Yes,
bigger.
there's more noise, it takes more energy to settle. But one thing that concerns me is your Hamming distance for the pattern C, which
Yeah.
should be random, right?
Yes.
Okay, pattern C for noise 0, your performance of pattern C is very good, right?
Yes.
It's equivalent to patterns A and B, right?
yeah.
But we know that pattern C should be random.
Yes.
So it is correct, because random means there's a chance that that's what it could be.
Yeah.
But you might want to go back and check whether your random thing is really random.
Okay.
Okay? Yeah, because this concerning, given what we saw just now from another simulation, this should be not 0, right? For the green
Yeah.
one. Yeah,
Maybe
that's
more.
what we would expect, right?
Yeah.
Yeah, so let's go back and check that. But
Okay.
yeah, cool, great. Anyone else? Haven't finished, Ben? 1 minute? Well, I think it's okay because time's up anyway. So we'll kind of let people go for lunch. But I want to finish up one last thing. I mean, if you have questions, you can ask after class. But I want to finish one last thing for today, and then the rest of it we can continue offline. Is the tokens? Okay, I talked about tokens. Okay, so in class, in theory, right now, I've always said just inputs. And I've talked about the inputs as n-bit words or stimuli or items. Okay, so these are items. And I never said anything about tokens. And in some of my notes, you will see that I've used the word tokens. And in Agarwal, the chapter, and also in other neural network books, you will see the label called tokens. What are tokens? Okay. A token is, do y'all play the, 你们有去那个电动游戏 arcade machine 吗？有吗？就是投币嘛，对不对？ You need to put a coin in and then the computer game will run, right? Or you put a token in and then the thing will roll 那种 machine like 它就会滚啊，然后就会做很多东西。就是 initial thing 你放进去，然后 the whole mechanism will run. That's a token, right? So these are tokens. Whatever it is, 一种投币，一种 initial state， 一种刺激的一种那个东西，然后你放进去 ，OK， then 整个 mechanism